DC current cannot flow through the branch of a circuit. Heavy water, which is used in the nuclear reactor, is a compound of heavy oxygen and heavy hydrogen. Nuclear reactor at Kaiga is a power reactor. Loudness and pitch of a sound depends upon both intensity and frequency. The next problem, again a problem on force between two long parallel conductors. In the previous sessions, we have calculated the resultant force. If you abide by that sessions, calculate, here you can see the resultant force will be towards C. Next one. Curie-Weiss law is obeyed by iron at a temperature. So, iron is a ferromagnetic material. So, very clearly on analysis we have told iron is a ferromagnetic material. And Curie's law is obeyed by paramagnetic materials. We told Curie's law says the susceptibility of a paramagnetic material is inversely proportional to temperature. Now, here transition takes place only if the temperature is greater than Curie temperature. So, for iron, which is a ferromagnetic material, to obey Curie-Weiss law, the temperature has to be above Curie temperature. Dimensional formula for inductance, coefficient of self-inductance. How did we represent coefficient of inductance, students? L. So we know E is equal to L di by dt. Idana now self-induction concept in that takoltivi. E equals L di by dt. Dimensional formula for L baribeku. So L equals E dt divided by di. Rearrange ಮಾಡ್ಕೊಂಡೆ, manipulate ಮಾಡ್ಕೊಂಡೆ. So L equals E dt by di. E ಅಂದ್ರೇನು? EMF, potential, where we told it is W by Q. Electric potential definition, work done to move a charge from infinity to a point in the field. Mathematically, E is W by Q. So this is time divided by current. Notice step by step simplification ಮಾಡ್ಕೊಳ್ಳೋಣ. So easily I understand the solution. Work M L square T minus 2. Time is T. Q is charge. How do I write the formula for charge? It is ampere time. Again, current is ampere. T and T gets cancelled. So this is M L square T minus 2 ampere minus 2. This is the dimensional formula for inductance. Nodi. A magnet, North pole, South pole. One magnet ide. Idu North pole, idu South pole. Is suspended using a spring. And while it oscillates, it moves in and out of the coil. The coil is connected to a galvanometer. Then as the magnet oscillates, ಇಲ್ಲಿ ವೆರಿ ಕ್ಲಿಯರ್ ಆಗಿ ಹೇಳಿದ್ದಾರೆ, ಮ್ಯಾಗ್ನೆಟ್ ನಾರ್ತ್ ಪೋಲ್ ಟು ಸೌತ್ ಪೋಲ್ connected to a spring. Now the magnet moves in and out of the coil. It moves in and out of the coil. And the coil is connected to the galvanometer. First, let us analyze. When the magnet moves in and out, magnetic flux is changed, current is induced. So in which direction the galvanometer should point? Lenz's law. In and out, current is induced in anti-clockwise direction. So the deflection of the galvanometer is to the left and right. As the magnet moves in and out, there is something called damping effect. The amplitude of the current is suppressed. So the amplitude goes on decreasing steadily. So the fourth option is the answer. By Lenz's law, since current is induced in anti-clockwise direction, the galvanometer should point left to right. Damping effect is coming into picture. Amplitude is decreased and a steady decrease in amplitude. Again, very much done in the previous sessions. Use the relation R is V by Ig minus G. This gives the high resistance to be connected in series to convert a galvanometer into an voltmeter, and B will be the answer. On meter bridge, exactly what we did in the last class, 20 ohms is the answer. Now, in the circuit shown, the internal resistance of this cell is negligible. And somewhere R is equal to 0. There is a circuit given where internal resistance of this cell is negligible. The steady current in the 2 ohm resistor has to be calculated. Current flowing through the 2 ohm resistor. ನೀವು ಈ ಸರ್ಕ್ಯೂಟ್ ಅನಲೈಸ್ ಮಾಡಿದ್ರೆ there is a capacitor connected in series with a 4 ohm resistor, and therefore no current can flow through this branch. DC current cannot flow through the branch of a circuit where a capacitor is present. Simple ಆಗಿ ಹೇಳಬೇಕಾದ್ರೆ capacitor blocks DC. ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ. ಯಾವುದೇ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಯಾವ ಭಾಗದಲ್ಲಾದ್ರೂ ಕೆಪಾಸಿಟರ್ ಕನೆಕ್ಟ್ ಆಗಿದ್ರೆ ಅಲ್ಲಿ DC ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ನಮ್ಗೆ ಯಾಕೆ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್ ಅದು DC-ನೋ AC-ನೋ? ಸೋರ್ಸ್ ನೋಡಿ, ದಿಸ್ ಇಸ್ ದ ಸಿಂಬಲ್ ಫಾರ್ DC. AC ಆಗಿದ್ರೆ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಕೊಟ್ಟಿರೋರು. So, if at all a capacitor is connected in a circuit, there cannot be flow of DC. Now, 2 and 3 are connected in parallel. So, the effective resistance is 2 into 3 divided by 2 plus 3. So, this is somewhere 6 divided by 5. So when you divide 6 divided by 5, so 6 divided by 5 divided by 5, ones are 5. Somewhere it turns out to be 1.2 ohms. Now, if you observe, this 1.2 and 2.8 are in series. So 1.2 plus 2.8, somewhere 4 ohms. So the effective resistance turns out to be 4 ohms. Current flowing is E divided by R, 6 by 4. Again 1.5 amps. This is the main current. But what is asked? Current through the 2 ohm resistor. I call that I1. Matpuna previous madudvalla branch current formula. So this is main current into resistance of other branch divided by sum of resistances. 101 times I have used this notion on the branch current. So this is main current is 1.5 into 3 divided by 1.5 plus 3. So nearly this is 4.5 divided by 4.5, nearly 1, which has to be 0.9 ampere. Here, induced EMF maximum NAB omega sin theta. How many turns are there? 300 turns. So I write 3 into 10 power 2. Area is 25 centimeter into 10 centimeter. So this is 25 into 10 into 10 power 4 centimeter alirodrinda. Omega is 50 cycles per second. So 2 pi into 50. Magnetic field strength 4 into 10 power minus 2 into sin 90. Simplify this. 30 pi should be the answer. In an LCR circuit, potential difference between the terminals of the inductance is 60 volts. ಇದನ್ನ VL ಅಂತ ಕರೆಯೋಣ. Potential between the terminals of the inductor VL and the capacitor is 30 volts VC, and that between the terminals of the resistance VR. Now, what is the supply voltage? Again, a common repeated problem. The supply voltage is the resultant voltage VR square plus VL minus VC whole square. So it is 1600 plus 60 minus 30 is 30. So this is root. So the answer is 50 volts. The spectrum obtained from the chromosphere of the sun, line absorption spectrum. This is during total solar eclipse. Heavy water, which is used in the nuclear reactor, is a compound of heavy oxygen and heavy hydrogen. So, heavy oxygen mixed with heavy hydrogen is what is heavy water. Nuclear reactor at Kaiga is a power reactor. Nodi vella theory based. When a body moves in a circular path, no work is done by the force. Why? Whenever a body moves in a circular path, force and displacement are perpendicular to each other. Yalla previous session alli discuss madidini. W is Fs cos theta. Circular path F and S are perpendicular, so no work is done. This is again an assignment. 8 bullets will be the answer. Motion in one dimension will help you to solve this, or you can also use work energy theorem. Two bodies of mass 1 kg and 2 kg have equal momentum. Then the ratio of their kinetic energy, we know kinetic energy is P square by 2m. Expression for kinetic energy in terms of momentum. Momentum is same ant helidare. So E is proportional to 1 by m, which means E1 by E2 is equal to m2 by m1, which is 2 by 1. So 2:1 is the answer. Loudness and pitch of a sound depends upon both intensity and frequency. Absorption of coefficient for an open window. Acoustics in the previous syllabus alittu. So there the answer is 0. Melday's experiment, the frequency of the tuning fork and frequency of the waves. Here in Melday's experiment, resonance is achieved. Resonance andreno, two frequencies which match each other. Clearly, the frequency of the tuning fork and the frequency of the strings are in the ratio 1:1. Why? Resonance is achieved the frequency of the tuning fork and vibrating string becomes the same. Therefore, it is 1:1. And this is based on Doppler effect. Same question. Previous session I have worked out as the third question, 3 meters per second. So if you observe here, a very interesting paper to solve. Such papers are challenging. Take out and work. You will become perfect with the topics. We'll come up next. Until then, have a nice time.